In this video, we will learn how to find out the change in the equilibrium price when the slope of the demand curve changes. In the earlier video, we have solved for the change in the equilibrium price when the intercept of the demand curve changes. Options are being given here. Let us first find what was the question. We are being given the market model for a single commodity as QD is equal to A minus BP. QD denotes the quantity demanded of a particular commodity. P denotes its price. A, B, C, D all are greater than 0. We have to find out the change in the equilibrium price when the slope of the demand curve changes. Okay, now we know first we need to find out the equilibrium price, then we can find out what happens to the change in the slope, okay, of the demand curve. At equilibrium, we know in the earlier video that demand should be equal to supply. That means quantity demanded should be equal to let me write it here. So at equilibrium, what happens? At equilibrium, quantity demanded should be equal to quantity supplied. That means we equate QD is equal to A minus BP should be equal to the quantity supplied. So let me be very clear here. Okay, this is our demand function and it should be equal to our quantity supplied function, which is minus C plus dP. Okay, now we need to solve for P. When we solve for P, we will get, when we solve this for P, we will get P should be equal to A plus C upon B plus D. Okay, this will be our equilibrium price. Graphically, what exactly is meant by this? This is our demand function, this is our supply function. So this denotes our equilibrium price if we denote price on the vertical axis and quantity demanded on the horizontal axis. So this is our equilibrium price. Now we need to find out what happens to the slope, what happens to the, or what will be the change in the equilibrium price when the slope of the demand curve changes. Okay, what is the slope of the demand curve? This B denotes the slope of the demand curve. Okay, now here we have B in the equilibrium price function. So the change in the equilibrium price, that is the partial derivative of the price, this price function, with respect to the slope of the demand function, that is the slope is B. We need to partially differentiate this this function with respect to B, because B denotes the slope. Now since B is in the denominator, we have to apply the quotient rule. That means in the quotient rule, what we do, we write the denominator function first. That is, I will write it here, B plus D. Then I multiply it with the partial derivative of the numerator function with respect to B, that is D upon D B of the numerator function, which is A plus C. Then we subtract and write the numerator function first, that is A plus C, and then we multiply it with the partial derivative of the denominator function with respect to B, that is the derivative of B plus D, whole divided by B plus D whole square. B plus D whole square. This is very simple. If we have a function h of x is equal to f of x upon g of x. So if we have a function, this function in this form, then the derivative of h prime x is equal to, we write the denominator function first, then multiply it with the numerator function's derivative. Then we subtract and write the numerator function first and multiply it with the derivative of the denominator function, that is g prime x. This is from the quotient rule of differentiation, and we divide it by the denominator function, but whole square. I will not go into the detail, you know it pretty well. I have explained it in n number of videos. where I don't know the value of n. So doing this, so we have here b plus d, that means the change in the equilibrium price when the slope changes, which is b, will be equal to, so here we have b plus d. Now the derivative of this function a plus c with respect to b, since no b is involved in the both terms, its derivative will be equal to 0, minus, then we have a plus c, and what is the derivative of this function b plus d with respect to b? Derivative of b is 1, derivative of d is 0, so we get here 1 plus 0, and we divided by b plus d whole square, that means the change in the equilibrium price when the slope changes, that is dB will be equal to, so b plus d times 0 is 0, then we get here minus a plus c, minus a plus c times 1 will be equal to a plus c divided by b plus d whole square. So this should be a correct option, that is this B option must be correct. So graphically it simply means if we have the downward sloping demand function, upward sloping supply function, initially our equilibrium price will be P, which is equal to this thing. Now what happens, this is our demand function, this is our supply function. We are being told what happens, the slope. Either slope can become steeper, that means our equilibrium price should have been here, or it could have become flatter, that means our equilibrium price should have been there. In both the cases, what we need to find out, the impact of the change in the equilibrium price when the slope changes. We simply partially differentiate the equilibrium price function with respect to the slope of the demand function to get the required result. I hope I make myself clear in this video and you are finding these videos helpful. Thank you.